Hello. This lesson we're going to be looking at sketching functions. So the first thing you need to know is what a function is. Functions are any relations that only have one value for every x value. So what that means is if you had a graph, such as, let's just draw a few graphs that you would have seen before. We'll have a circle graph, and let's put a couple more in. Let's say we had linear graph, a parabola, and let's even draw one like this. So for any of these graphs to be a function, they're only allowed to have one y value for every x value. So as you go along the x-axis, any x value point, so I'm going to pick this point here, there should only be one y value that corresponds to it. If I look up here, I've got this point and this point, so it has two, so it's not a function. Now a short way of doing this is what we call the vertical line test. So vertical line test is how do we determine if something is a function or not. So for any x value, just draw a straight line down, and if it crosses the graph more than once, then it is not a function. So this is not a function. And you see over here, it only crosses it once, no matter where I draw that line. So this is a function. This one over here, no matter where I draw it, crosses it only once, so that's a function. And if it crosses it more than once, over here it crosses it 0 times, but there crosses it twice, so that is not a function. So for a relation, all of these graphs here, relations, for them to become a function, they have to pass the vertical line test. Now you can restrict the domain to turn a relation into a function, but we'll look at that a little bit later in the topic. For now, just a couple of notation things you should be aware of. If you're asked to find the image, it's saying find the value of y if you're given the x value. The pre-image is going the other way. So if you know the y value, what is the x value? DOMF and RANF are just shortcuts for saying what is the domain and range of a function if that function was denoted with the lowercase f. You can use any lowercase symbols. You could call a function g of x, you can have h of x, and so then we'd just say the DOM g, RAN g. It's just a shortcut or shorthand way of saying the domain and range. So most commonly you'll see in textbooks and tests and exams and things like that, they'll use lowercase f for function, but it doesn't have to be that. It can be any lowercase letter. And often you'll be sketching more than one function on the same set of axes, so you'll have a range of different letters. Let's look at one example. This thing written over here. Now it looks pretty wordy. There might be a few symbols that you're not too accustomed to, but all it's really saying is, hey, can you sketch the graph of y equals x plus 3 times x minus 5. So you can see that bit in there, that's the graph. And can you sketch it with a domain of -5 to 5? So that's your x values. Okay, so if we were reading this out, we'd say function f such that it's from -5 not inclusive to 5 inclusive. And we should have a little arrow there to the reals. The function f of x equals x plus 3 x minus 5, and x is between -5 and 5. So f of x, we can see, just takes the place of the y. Alright, so we're actually sketching this function here. So if I didn't have a restriction on the domain, sketching x plus 3 times x minus 5, I should recognize that's a parabola, and it's in x-intercept form, so it's going to have intercepts at -3 and +5. And halfway between there would be my turning point. So it's going to look something like this. Look at that, I missed the 5. Okay, so that's what the whole graph would normally look like. But this time I want to only show it between -5 and 5. So -5 down here, and you see 5 is actually on the x-axis, so I'm going to rub off this part. And I can see from this little equal sign here, or this square bracket here, that it does equal that point. So on this point, I've got a colored in circle, and I know that's the point 50 because that's my intercept. over here at -5, it's going to be somewhere at the top here. It's a curly bracket and it's not equal to over there. So I'm going to have a hollow circle. The last thing to do is to actually find out what the y value is there, and also the intercept down the bottom here. So at the top, I know that's -5. I don't know the y value. So using our function notation, our function is f in terms of x. So if I wanted to say, can you find the value of the function when x equals -5, I can just shorthand that and write f, open the brackets, -5. You can see I've just swapped out the x with the -5. So rather than have to write a whole sentence or a paragraph telling you, hey, can you substitute in x equals -5 and find what it equals, I just write f in brackets -5, and you should be able to interpret that as, hey, I need to sub in -5, find out what it equals. So our function was x plus 3 times x minus 5, so I'm going to put -5 in the place of the x's. So I'm going to have -5 plus 3, -5 minus 5. And solving that through, -5 plus 3, -2 times -10, I'm going to get +20. So that tells me that that point is -520. So this value is going up into there. Now, last thing, we've got an intercept that we haven't labeled. So you should always label endpoints and intercepts. So that is going to occur when x equals 0. So I can write that as f of 0 and do the same process. So I would have 0 plus 3 times 0 minus 5. So I get 3 times -5 is -15. Okay, so that point would be 0, -15. And that's my graph. You can see it looks like the parabola, however it's just been chopped off at -520 and 50. And the main thing to be careful of is whether it's an open or a closed circle. And we can tell that by in the equation, when we're given the domain up the top here, it mentions the function, and there's a domain there, -5 to 5, and the circle bracket or the curved bracket tells you it doesn't equal -5, square bracket tells you it can equal +5. It's also stated at the end there as well. Okay, so all the best for sketching functions. Next video we're going to be looking at piecewise functions or hybrid functions.